Hello students, in the previous video we did one shot of the chapter areas related to circles. Today we are going to solve the important questions of this chapter. Before solving the questions, let's go through the formulae which I had already explained in the previous video. So area of circle is pi r square, circumference of a circle is 2 pi r, area of sector is theta upon 360 into pi r square. Length of arc is theta upon 360 into 2 pi r. Area of segment is area of sector minus area of triangle, where area of triangle is equal to half into r square into sine theta. So, how to find area of triangle? If theta is 30 degree, using this formula, we will get area of triangle as 1 upon 4 r square. If theta is 45 degree, then area of triangle will be 1 upon 2 root 2 into r square. If theta is 60 degree, then area of triangle will be root 3 upon 4 r square. If theta is 90, then area of triangle will be half r square. Now just see perimeter of sector. So this A to O, O to B and this whole arc AB is perimeter of sector. So perimeter of sector is length of arc, that is AB plus 2 times of radius. So when we add these two, we get perimeter of sector. I hope the formulas are clear to you. So let's solve the questions. The first question. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Find the length of the arc. So here in this question, it is given a circle is of radius 21 centimeter. And the arc AB subtends an angle of 60 degree at the center. We need to find the length of the arc. You should all know that length of the arc is theta upon 360 into 2 pi r. Put the values where theta is given here as 60 degree. So 60 upon 360 into 2 and the value of pi is 22 upon 7 and the radius is here 21. Cancel it. Hope you all know how to cancel the terms. So we are left with 22. So the length of the arc is 22 centimeter. Hope the first part is clear to all of you. So see the second part. Area of the sector. We need to find the area of the sector formed by the arc. We need to find this area. Wait. We need to find this area. So you all know the formula of area of sector. Area of sector is equal to theta upon 360 into pi r square, where theta is 60 upon 360 into the value of pi is 20 upon 7 and the radius is given, that is 21 square. Cancel. So we are left with 11 into 21. So multiply 11 and 21 and you get 231 centimeter square. So area of sector is 231 centimeter square. Hope the first question is clear to all of you. Let's move to the second question. The circumference of a circle is 44 centimeter. Calculate the area of its quadrant. So when a circle is divided into 4 equal parts, then each part, that is each sector, is called as a quadrant, and the theta for each quadrant will be equal to 90 degree. How it is? We know the complete angle is 360 degree, and if we divide this 360 into 4 equal parts, then we get the theta of each sector as 90 degree. So since circumference is given here, so we are going to use the formula of circumference of a circle, which is 2 pi r. Circumference is given here as 44 centimeter, and we know the formula of circumference of a circle, that is 2 pi r is equal to 44. The value of pi is 20 upon 7 and radius we need to find. So it is 2 into 20 upon 7 into r, which is equal to 44. So we can cancel this 2 and this 44, and even we can cancel this 22 and this 22. We are left with 1 here. So r will be equal to, shift this 7 there. So it is 7 into 1, which is 7 centimeter. So by using the formula of circumference of a circle, we got the radius. So radius is 7. Now we can easily find the area of the sector, that is the quadrant. So area of sector is theta upon 360. Wait, I am writing. Area of quadrant, which is a sector, theta upon 360 into pi r square, where theta is 90. So for the quadrant, the theta is always 90. So the pi is 20 upon 7, and radius we already found here, that is 7 into 7. So in place of using this theta as 90 upon 360, you can simply write the formula of quadrant as 1/4 of pi r square. So this is the formula for area of quadrant. So just check, if we cancel, still we are getting this as 1/4 of pi r square. So you can straight away use this formula, that is area of quadrant is equal to 1/4 of pi r square. Cancel the value. So we are left with 11 into 7, that is 77 upon 2, which is equal to 38.5 centimeter square. So we got the area of quadrant as 38.5 centimeter square. Let's see what is there in question number 3. The area of sector of a circle of radius 14 centimeter is 154 centimeter square. Find the length of the corresponding arc of the sector. So as you all know, area of sector is equal to theta upon 360 into pi r square. So let me tell you, we have one more formula to find the area of sector, that is half into length of arc into radius. This is one more formula to find the area of sector. So just see how. Half, and you all know the formula for length of the arc. Length of the arc is theta upon 360 into 2 pi r. This is length of arc, and now write this arc. Just see, 2 and 2 gets cancelled. Now what we are left with? Theta upon 360 into pi r into r is r square. Just check. This formula and this formula both are same. Just here length is being used, so area of sector is half into L into R. So as in this question length is being asked, length of the corresponding arc of the sector is being asked. So instead of using this formula, we'll be using half into L into R to make your calculation easy. Let's move. So in this question, area of sector is given here as 154 centimeter square. And as right now I just discussed with you, we should be using the formula half into L into R, which is also the area of sector. And this is equal to 154 centimeter square. So here we are given with the radius, length we need to find, and radius is given here as 14 centimeter. So just let's replace. So radius is 14, which is equal to 154. Cancel it. So length will be equal to, we can cancel this 154 with this 7. So length we are getting it as 22 centimeter. So this is the length of the corresponding arc. So this is the length of the corresponding arc of the sector. The fourth question is, the perimeter of a sector of a circle is 56 centimeter and the area of the circle is 64 pi square centimeter. We need to find the area of sector. Just check in this question, radius is missing. So we are going to find the radius with the help of area of circle. So area of circle is equal to 64 pi square centimeter. So you all know the formula of area of circle, that is pi r square equal to 64 pi. Cancel this pi. We are left with r square is equal to 64, where radius will be equal to 8 centimeter. So we found the radius. Just now let's apply the formula for perimeter of a sector. Wait. Okay, since radius we got it as 8 centimeter, and you all know that perimeter of a sector is from A to O, O to B, and this arc AB. So which is length of the arc. So radius plus length of the arc. So we all know the perimeter of a sector is equal to, can you see, 2 times of R plus length of the arc. So put the value. Perimeter of sector is given in the question, which is 56 centimeter, and radius we found it as 8. So perimeter is 56 centimeter and we got the value of radius as 8 plus length of the arc. So solve it. Shift the 16 to the other side. So length of the arc is 56 minus 16, that is equal to 40 centimeter. So we have the length and we have the radius. What is missing to find the area of sector? We need to find the area of sector, and as I shared in the previous question, we have two formulas for finding area of sector. Wait. So area of sector is equal to theta upon 360 into pi r square, and the other formula is half into L into R. So as per the question, we have found the radius and we also found the length of the arc, and we need to find the area of sector. So we are going to use this formula, that is half into L into R, to find the area of sector. We will not use this formula because we are not knowing what theta is. Hope this is clear to all. So area of sector using the formula half into L into R, where length is 40 centimeter, half into 40 into, and we got the radius as 8 centimeter. Just see, we got the radius as 8 centimeter. So put our radius as 8. Cancel. So 40 into 4 is 160 centimeter square. So we got the area of sector as 160 centimeter square. Let's move to the next question. The fifth question is, the length of the minute hand of a clock is 6 centimeter. Find the area swept by minute hand when it moves from 7:05 p.m. to 7:40 p.m. As in this question, it is being asked, find the area swept by the minute hand. That means we need to find the area of sector here. So where the length of the minute hand is given, that is 6 centimeter. So length of the minute hand is radius of the sector. Just see, as I already shared with you all, that degree covered by the minute hand in 1 minute is equal to 6 degree. How it is, I explained in my previous video. So now time duration from 7:05 to 7:40 p.m. will be 35 minutes. This you all know. When minute hand moves from 7:05 p.m. to 7:40 p.m., it covers 35 minutes. So let's find how much degree it is covering. Degree covered in 35 minutes is equal to 35 into degree covered in 1 minute, that is 6. 35 into 6 is 210 degree. So now let's find the area. So since we need to find the area swept by the minute hand, area swept by the minute hand. Ultimately, we need to find here area of sector, that is theta upon 360 into pi r square, where theta is 210 upon 360 into 22 upon 7, and radius is the length of the minute hand, which is given here as 6 centimeter. So in place of r, we are going to write it as 6. 6 into 6. Cancel. So we get the area swept by the minute hand as 3 into 22, that is 66 centimeter square. So the sixth question is, find the area of the major segment where the radius of the circle is 35 centimeter and angle AOB is given as 90 degree. So you all know the formula of area of major segment. That is area of circle minus area of minor segment. Area of circle you all know, which is pi r square, minus, now here area of minor segment is area of sector minus area of triangle. See, this is area of minor segment and we need to find the area of major segment. So from the area of circle, we will subtract the area of minor segment. Then we will get the area of major segment. So now just formula I already written here. So solve it now. Area of sector, you all know the formula, that is theta upon 360 into pi r square, minus here area of triangle, since theta is 90, so this AOB becomes a right angled triangle. So you all know the formula for area of right angled triangle, that is half into base into height, that is half into r into r. So now solve further. Pi r square minus, since theta is given here as 90 degree, so 90 upon 360 into pi r square minus When we open the bracket, this minus and this minus makes it positive. So it is half r square. Cancel it. So we are left with pi r square minus 1/4 of pi r square plus half r square. Solve this first. Solve this first. So can you see in both the terms pi r square is common. So pi r square will come out, and here we are left with 1 minus 1 upon 4 plus half r square. So it is 3/4 of pi r square plus half r square. Now from these two terms again we are able to see half r square is common in both the terms. You can either take half r square or only half square as you wish, but it's better to take half r square common out. So we are left with 3 upon 2, and the value of pi is 22 upon 7 plus, since half r square has come out, so we are left with 1 here, half into radius is given here as 35. Cancel this. So 3 into 11 is 33 upon 7 plus 1. So it is half into 35 into 35 into, when we solve this we get 40 upon 7. So cancel it. So we get 35 into 100, that is 3500 centimeter square. So the area of segment, major segment, we get it as 3500 centimeter square. Hope this question is clear to all of you. Now let's move to next question. So the next question here is, sides of a triangular field are 15 meter, 16 meter and 17 meter. Let me draw a triangle. So with the three corners of the field, a cow, a buffalo and a horse are tied separately with ropes of length 7 meter each to graze in the field. Find the area of the field which can be grazed by the three animals. So that means what, here it is given that all the three animals are tied with a long rope of 7 meter. So even all three animals are tied with a rope of length 7 meter. So we need to find how much area is grazed by all the three animals. So here can you see? So this area is the area of sector. We need to find the area of these three sectors. So this much area is grazed by all the three animals. So just see, And you all know the formula for area of sector. Area of sector is theta upon 360 into pi r square. Since for this triangle the angle is not given, so we will assume this, we'll assume this theta as theta 1 and this theta as theta 2 and this theta as theta 3. So now to find the area grazed by all these three animals, we are going to find the area of this sector and the area of this sector. So area grazed by the three animals is equal to the area grazed by cow will be theta, which we have taken theta as theta 1 upon 360 into pi r square, plus area grazed by the buffalo will be theta 2 upon 360 into pi r square, plus the area grazed by the horse will be theta 3 upon 360 into pi r square. Can you see in these all three terms, first term, second term and third term, what is common in all these three? Pi r square upon 360 is common in all these three terms. So we have taken this common out. So from this term, the first term, we are left with theta 1. From the second term, we are left with theta 2. And from the third term, we are left with theta 3. So just check the sum of theta 1 plus theta 2 plus theta 3 will be equal to how much? Since these all three are the angles of the triangle, so you all know that the angle sum property of a triangle is equal to 180 degree. So in place of theta 1 plus theta 2 plus theta 3, we are going to write 180 degree. So it is, put the value of pi here, it is 22 upon 7 and the radius is here, since the animals are tied with the rope of 7 meter, so the radius is 7 into 7 upon 360, and the sum of these three angles will be equal to 180. So cancel it. So we are left with 11 into 7, which is equal to 77 centimeter square. So this much area is grazed by these all three animals. So hope this question is again clear to all of you. Let's move to the next question. So in this question, a horse is tied to a peg at one corner of a square-shaped grass field of side 25 meter by means of a 14 meter long rope. Find the increase in the grazing area if the rope was 21 meter long instead of 14 meter. So here at present it is given that a horse is tied to a rope of length 14 meter. And since this is a square shaped gross field, so angle of each square is of 90 degree. So now for theta here is 90 degree. So now since we need to find the increase in the grazing area, so if the horse is tied to a rope of 21 meter long, then the horse will be grazing this much area. So we need to find the increase in the grazing area. Earlier the horse was grazing only this much area. Now since the length of the rope is being increased, so this is the increase in the grazing area. So to find this increase in the grazing area, we are going to find the area of sector, that is this, where radius is 21 meter. From this area of sector, we are going to subtract the area of sector where the radius is 14. So from the area of sector with radius 21 meter, we are going to subtract the area of sector of radius 14 meter. Then we will get the increase in the grazing area. Just see how to solve. Increase in the grazing area is equal to theta upon 360 pi r square. So I am taking this 21 meter as capital R, the radius, and this 14 as small r. So minus, we are going to subtract the area of sector with radius 14 meter. So theta upon 360 into pi r square. Just check that in these two terms, what is common? Theta upon 360 into pi. This is common, so take this out, and what we are left in the bracket, r square minus r square. So since theta is equal to 90, replace it upon 360 into 22 upon 7, and just see r square minus r square is in the form of a square minus b square. So you all know a square minus b square is a plus b into a minus b. So please apply this formula here. So it is r plus r into r minus r. Cancel this. So it is 1 upon 4 into 22 upon 7, and capital R is 21 plus small r is 14. So it is 21 minus 14. Cancel this. So it is 11 upon 2 into 7 into 21 plus 14 is 35, and 21 minus 14 is 7. So this 7 and this 7 gets cancelled, So 11 into 35 upon 2, which we get 385 upon 2, which is equal to 192.5 meter square. So the increase in the grazing area will be equal to 192.5 meter square. Hope this question is clear to all of you. Let's move to next question. So today this will be your last question. In the figure, two concentric circles with center O have radii 21 cm and 42 cm. If angle AOB is equal to 60 degree, find the area of the shaded region. So here shaded region is given. So you need to find the area of the shaded region. So to find the area of the shaded region, are you able to observe? To find the area of this shaded region, we are going to find the area of the circular ring first, including this. So you all know, to find the area of this circular ring, the formula will be, from the area of big circle, we will subtract the area of small circle. So in this way we will get the area of this circular ring. So as soon as we get the area of this circular ring, now from this we are going to subtract, we are going to subtract this from the area of the circular ring. So, and which portion is this? How you are going to find this portion? So to find this portion, we are going to find the area of this sector where the radius is 42 centimeter. I am taking this as capital R. And from this sector, we are going to subtract the area of this small sector, for which the radius is 21 centimeter. So I am taking this radius as small r, that is 21 centimeter. So from the area of the big sector, that is AOB, if we subtract the area of sector OCD, we get the area of this region. So from this area of the circular ring, we will subtract the area of this region. So just find. So to find the area of this region, what I said, the formula will be area of the sector, that is 3 theta upon 360 into pi r square minus theta upon 360 into pi r square. So if we use this formula, we will get the area of this region. So we are going to subtract the area of this region from this. So I am writing the formula again finally. From the area of this circular ring, I am going to subtract the area of this region, that is A, B, D, C. this area we will subtract from the area of the circular ring. From the area of circular ring, we will subtract the area of A, B, D, C. So, I am writing the final formula now. Area of shaded region is equal to area of circular ring. From this, I am going to subtract the area of A, B, D, C. So, the area of circular ring is pi r square minus pi r square. From the area of big circle, we will subtract the area of small circle. Minus, to find this area of ABDC, to find the area of this ABDC, I just explained here how to find area of sector, that is theta upon 360 into pi r square. Area of sector with radius 42 centimeter minus area of sector with radius 21 centimeter. So now just see, in these two terms pi is common, so we'll take the pi common out, and inside the bracket it will be r square minus r square. So again, from these two terms we are able to see the common is theta upon 360 into pi, and in this term r square is left, and in this term small r square is left. So again, now are you able to see from this term and from this term what is common? So here pi is there. Can you see? Pi is common, and even r square minus r square. Pi r square minus r square is common in both the terms. So I am going to take this common out. Pi r square minus r square. So in this term, as we have taken all out, so only one is left here, minus here it is theta upon 360 is left. So now put the values. Since theta is given here as 60 degree, theta is given here as 60 degree, and radius is capital R is 42 and the small r is 21. So replace the value. So the value of pi is 20 upon 7, and again this r square minus r square is in the form of a square minus b square. So we will write this as a plus b and a minus b. So that is r plus r into r minus r. 1 minus, since theta is 60 upon 360. Cancel this. So 22 upon 7, capital R is 42 and small r is 21. So here 1 minus 1 upon 6 is 5 upon 6. Solve it. This is 63 into 21 into 5 upon 6. So when we solve this now, cancel this, 7 and 63, so we get 9 here. Cancel this and then cancel this also. So now multiply 99 into 35. Multiply and write the answer. We get the answer here as 3465. Unit is centimeter square. So the area of the shaded region is 3465 centimeter square. Now check your understanding by solving this question and send the answer in the comment section. Do mention which formula have you used to find the answer. Hope this video was helpful to you. Do more and more practice to score good marks. All the best.